Good afternoon, YouTube, and welcome to what is a bit of a different video from me today. One of the things that a few different people have asked for me to do as a part of my YouTube channel is whole topic summaries. So that's what I've decided to try out for today's video. So obviously this is the first time I'm trying this, so all feedback via any medium would be hugely appreciated to let me know whether you think it's helpful in this particular video itself, how you feel future videos could be altered to be improved, and whether you think that you would watch a video of this nature. So I've chosen today to start with testing for gases, water, and ions. And I've split my whiteboard into those three distinctive areas. So we're going to start with how we test for 5 different gases. We're then going to have a look at how we can test for water using a physical method and a chemical test. And then we're going to have a look at how we can test for both cations, which are our positively charged ions, and our anions, which are our negatively charged ions. Starting with our tests for the 5 different gases listed here. These are the gases that you need to know how to test for various GCSE specifications. Please make sure that you check your specification to make sure that you know which gases you need to be able to test for. So on here I have included the test for hydrogen gas, H2, oxygen, O2, carbon dioxide, CO2, ammonia, NH3, and chlorine, Cl2. Now, I've used some pre-drawn diagrams, which I thought would be better than what I could draw electronically on the screen. So we'll start with hydrogen. In order to test for hydrogen, we would add a lit splint to what we believed was hydrogen gas. And if it is hydrogen, the lit splint will go out with a squeaky pop. That's a key phrase that we need to include in our answers. Lit splint goes out with a squeaky pop. For oxygen, we're also using a splint, but this time the splint has to be glowing. Now, what I mean by the word glowing is when you light it and then blow it out, but it's not completely extinguished. You can see like the embers still burning. The scientific word we use for that is glowing. So to test for the presence of oxygen, a glowing splint will relight. And that would be the 2 marking points that you would get. Glowing splint for 1, relights for the second. To test for carbon dioxide, some students would be tempted to write about the fact that carbon dioxide does not support combustion, so a lit splint would go out if it was placed in carbon dioxide. But that is not unique to carbon dioxide. There are many gases that would do that. And therefore, we need a way of specifically testing for carbon dioxide. So what we do is we generate the CO2 in one test tube, and then we bubble the gas into a tube of lime water. And if that gas is carbon dioxide, the lime water goes cloudy. Now, lime water is not water that has had lime juice squeezed into it. Lime water is an olden day word for calcium hydroxide, and the calcium hydroxide, the lime water, goes cloudy because we are producing calcium carbonate, which is a solid, a precipitate, and that makes the contents of the tube look cloudy. Again, key things here is using the word lime water and recognizing that it is the lime water that goes cloudy. The next gas we'll have a look at is ammonia. So ammonia has the formula NH3. And ammonia gas, when released, will turn damp red litmus paper blue because ammonia gas is an alkali. Now, the litmus paper needs to be damp so that the gas can dissolve onto the paper and change its colour. The litmus paper has to be red, and you need to know that the litmus paper will turn blue, as shown by my lovely diagram. And then the final gas we're going to have a look at is chlorine. So chlorine gas with the formula Cl2 will turn damp litmus paper initially red if we start with blue, and then the key thing is that chlorine will bleach the litmus paper white. Again, the litmus paper has to be damp. If it is blue that we start with, the litmus paper would go red first before being bleached white, but you don't need to specify a colour of the litmus paper. If you were to use red litmus paper, that would also be bleached white by the chlorine gas. So those are 5 gases that, depending on which specification you are studying, you need to know how to test for. So questions might say, how do you test for this particular gas and what is the result? So for something like chlorine, adding the damp litmus paper is how you would test for the presence of the chlorine gas. The result is that the litmus paper would be bleached white. I've chosen my terminology really carefully so you can just match the wording that I have used here. Okay, so that was how we can test for different gases. On some GCSE specifications, we also need to know how to test for water. Now, there's 2 different types of tests we can do for water. One is a physical test, which requires us to test the melting point or the boiling point of the substance we believe to be water. And the second type of test we can do is a chemical test, which again will show us whether the liquid we believe to be water is water. So in terms of the physical test, we need to test the melting or the boiling point to make sure that it is either 0 for the melting point or 100 for the boiling point. So all my diagram here is trying to show is that if I heat the water, it should boil at exactly 100 degrees C. Now, if it boils at slightly below to slightly above 100 degrees C, it can still be water, but that would suggest that the water isn't pure, because a pure substance will boil at a single specific temperature, whereas an impure liquid will boil over a small range of temperatures. So we can very easily say whether this is water, but we can also use this to say whether the water is pure. So if it boils at exactly 100, we know we have pure water. That would be our physical test. We can do the same thing with the melting point if we wish to. The water would freeze at exactly 0 degrees Celsius if it was pure water. For the chemical test, we're using a chemical reaction to prove whether, again, the liquid we believe to be water is water. Now, we're going to use something called anhydrous copper 2 sulfate powder. And in my little diagram, that is the white substance in this crucible. And the anhydrous copper 2 sulfate powder is white, and the word anhydrous means without water. So that white powder starts with no water at all. Now, if when I add the water to my anhydrous copper 2 sulfate, if the colour changes to blue and we get blue crystals forming, then that proves that the liquid that I've added is definitely water. Because when I add water to anhydrous copper 2 sulfate powder, it becomes hydrated and the water gets locked into the powder and we get these lovely blue crystals being formed. Now that is actually a reversible reaction, which is beyond the scope of this video, but I wanted to keep that in there for those people who were interested in knowing that we can then take the blue crystals and we can heat up the blue crystals and drive off the water and regenerate the anhydrous copper 2 sulfate. That does not need to be mentioned as a part of the chemical test. For the chemical test for water, we add the water to the white anhydrous copper 2 sulfate powder, and if that white powder turns blue, then the liquid that I have added has to be water, because the only time we get those blue hydrated copper 2 sulfate crystals being formed is if they have water locked in to them. Okay, so that's how we can do both a physical and a chemical test to test for the presence of water. The final testing for element that I want to talk about now is how we can test for the presence of different ions. Now, ions can be split into 2 different categories. We've got our cations, which are positively charged, and we have our anions, which are negatively charged. And it's really important to understand that every single compound that we test will contain a positive cation and a negative anion. But the tests that we do for each of those components are different. So on each substance, we have to do the test for the cation and come to our conclusion. And then with that same sample, we'd have to do another series of tests to identify the anion. And then once we know what both ions are, we can say what the compound is. So for example, we take our unknown white powder, we prepare it suitably so we can do a flame test, and we get a lilac flame. That would tell me that the potassium ion, which is a cation, is present. Then I would take a separate sample of my white powder and I could add acid to it and I might see effervescence, and that would suggest to me that there were carbonate ions present. That would mean that the compound was potassium carbonate because it contained the potassium cation and the carbonate anion. Now, as with the testing for gases and as for the test for water, there's quite a lot of information just to learn and commit to memory here and to be able to recall when it comes to answering questions. Also, we need to make sure that we are learning all of the different tests that we need to know for our specification. So please do check your specification to see whether there are some additional ones that you need to know that I have included here, or whether there are some that I have included here that are beyond what you need to know. So, starting with the cations, we would start by doing a flame test. Now, the flame test is usually done on a solution. So if you are provided with a solid, the first thing you would need to do is to dissolve the solid into water to turn it into a solution. Once you have the solution, you can soak a splint into that solution and then you can place the splint into the roaring blue flame. It's really important that it is the roaring blue flame for two reasons. One, the roaring blue flame is hotter, and two, it will not mask the colour of the flame like the orange safety flame would. So using the roaring blue non-luminous flame is what we need to be using in a flame test. We can also use a piece of metal wire to do a flame test. Rather than turning the powder into a solution, we can use it as a solid. We can dip the wire into hydrochloric acid to clean it, stick that into the white powder and place that into the roaring blue flame, and you will get the same outcome. Here are 5 different flame colours that you'll need to know. So we've got red flame for lithium, an orange-red flame for calcium, a yellow flame for sodium, a lilac flame for potassium, and a blue-green flame for the copper ions being present. Now, if you do a flame test and you don't see one of these 5 distinctive colours, that would suggest that none of those 5 cations are present. We then need to do another test to identify what the cation might be. So that's where we'd move on to stage 2 after the flame test, and we would start adding to the solution in a test tube some sodium hydroxide with the formula NaOH. Now we'd be looking for 3 different observations here, either a blue precipitate, a green precipitate, or a brown precipitate, and they would be observed if we had copper 2 plus ions present, or iron 2 plus ions present for the green precipitate, or iron 3 plus ions present for the brown precipitate. Notice there are 2 different ways we can test for copper ions. We can do the flame test and see the blue-green flame, or we can add sodium hydroxide to the solution and we would get a blue precipitate. The word precipitate is a solid formed when we react 2 solutions together, and it makes the contents of the test tube look really thick and cloudy. We can no longer see through the test tube anymore. It's pretty obvious that these form as precipitates, but we do need to understand what that word means. So a precipitate is a solid formed when 2 solutions are reacted together. If we still don't see a recognisable observation, there is a 3rd test we can do. Once we've added the sodium hydroxide, if we have not seen the formation of a precipitate, we can warm the test tube in a hot water bath and place a piece of damp red litmus paper into the mouth of the test tube. If we then see that damp red litmus paper turning blue, that tells us, as discussed earlier in the video, that we have made ammonia gas. And if we have made ammonia gas, we have to have started with the ammonium ion, which has the formula NH4+. When that reacts with the sodium hydroxide and is warmed, it releases ammonia gas, which we observe through the damp red litmus paper turning blue. So that would be how we would test for the cations, and that would give us half of the composition of whatever compound it is that we are testing. Once we have established which cation we have, we can then go on to having a look at the anions. So the first thing that we do when we're testing for anions is we add an acid, and specifically we're going to be adding HNO3, which is the formula for nitric acid. Now, if we have a carbonate present in my solution, or if we have a solid sample of a carbonate and we add an acid to a solid carbonate sample, we will create effervescence, because when acids react with carbonate ions, we release carbon dioxide. Now again, going back to testing for gases, if we were to trap that carbon dioxide, we could bubble it into lime water, and the lime water would go cloudy. That would be additional proof that we definitely started with a carbonate and that the gas that we had made was definitely carbon dioxide. But effervescence on its own would be enough in this situation, because there are no other anions that we are interested in knowing the tests for. That would give us effervescence. So for carbonate ions, if we add nitric acid and we see effervescence, we know that we have carbonate ions. If we don't see effervescence, we move on to step 2, and to the nitric acid we have already added to that test tube, we can add AgNO3, which is silver nitrate. When we add the silver nitrate, we are looking for 3 different coloured precipitates. If it's a white precipitate, chloride ions are present. If it gives us a cream precipitate, bromide ions are present. And if it gave us a yellow precipitate, iodide ions would be present. Now again, if we have not recognised any of those 3 precipitates, then we need to move on and do a third test. Now the third test requires a fresh sample of our solution, and to that fresh sample in a clean chest tube, you are going to add hydrochloric acid and barium chloride. Now this also gives us a white precipitate. This would suggest now, however, that sulfate ions are present. Chloride ions give a white precipitate, but that white precipitate is made when we have added nitric acid and silver nitrate. Sulfate ions will give us a white precipitate when we add hydrochloric acid and barium chloride. So it's really important that you don't get those 2 confused. Now, for all of the information in this summary, I think flashcards are a really good way to revise this information. For the tests for the different ions and the tests for gases, you can have the formula of the gas or the formula of the ion on the front of the flashcard, and on the back you can have how we test for that particular gas or ion and what the outcome would be. And for your ion flashcards, you could colour code them if you were that way inclined, and then you can use the cards both ways, because you could either look at the formula and then you could describe how to do the test and what you would observe, or you could use the cards in reverse and have in front of you the test and the observation, and then you could be working out what ions you have. And the beautiful thing about flashcards like those is that other people can test you on them really easily. They're like really little quiz questions that anybody can test you on, because the correct answer is going to be on the reverse of the card. You could do the same thing for water. You could have physical test on the front of one and chemical test on the front of the other, and then you could explain how the test works on the back. And again, they could still be used both ways. In addition to that, I think the blurting method is potentially a good one here, which is where you would have a look at this summary, my video, or your own summary that you've made, for a short period of time to try and take in and absorb as much information as is possible. About 5 or so minutes later, you'd then get a blank piece of paper and you would try and regurgitate everything you had read from this summary or your own summary. And then you would be able to see what you had remembered and what you hadn't remembered, comparing your version that you've just scribbled to the original, and then you would add in a different colour all the information that you have not yet learnt. And then the next time you were to repeat that process, you would hope that the amount of annotations in the second colour would decrease, because every single time you look over this resource, you will learn more. That's testing your ability to actively recall information. The flashcards will also help with that process. So you could get tested on your flashcards, and then you could try the blurting method and write down onto a blank piece of paper as much as you could remember, having just been quizzed on your flashcards. It is really important, as I've said, that you check your specific GCSE specification to see which of these points you need to learn for the specification that you are studying. Okay, if anybody has any questions about the content of this video, or you'd like any help with revision strategies, or specifically questions to do with the content in this video, please do not hesitate to leave a comment on the video or contact me via social media or via my email, and I will get back to you as soon as I possibly can and provide whatever help I am able to. I really hope you found this video useful. As I said at the beginning, I'd really appreciate all feedback, because this is the first of this kind of video that I have put together, and I'd like to create more if they're going to be useful for you guys. Have a lovely rest of your day. Take care, everyone.